Okay, working on partial fraction decomposition, practicing the technique. So here's your example. I want you to be able to, first of all, we're going to rewrite that in form of a over, we'll factor this. What multiplies to give us -5 adds to give us a -4. So that one's going to be x minus 5 plus, we're going to determine what b is over the other factor, x plus 1. So we're going to use the method that you did previously. I want you to pause it and see if you can work your way through that. And see if you can determine what a and b is. Okay, just to check some progress as we go. So basically we got common denominator and we calculated our numerator there. So our numerator on the left hand side is now set equal to the numerator on the right hand side, and I distributed that out. The next step was to rearrange these so that these x terms were next to one another, and we factored out an x. Okay, now the next thing you want to do is you want to, let me see if I can highlight. So basically you're going to have your a plus b, let me keep it consistent a minute ago. So your a plus b is, that's the term that's in front of the x, and then we will have the -8 is going to be set equal to that. So okay, so we'll have this a plus b is equal to 3 right here, and the other one is a minus 5a is equal to -8. To solve those, I stack them up. There's lots of options here for elimination. I'm just going to multiply through by -1. Some of you may choose to multiply by 5 and get rid of b right there. It doesn't matter. We should get the same answers algebraically if we do things correctly. So solving, I get b is 11/6, and then I can choose to plug it back into either one of these equations. So plug it back into the first one and found out that a is 7/6. Okay, just to see it. Now this could be simplified to a different format as well, but I want you to distinctly see your a and your b there, and this will be our partial fraction decomposition. Okay, so before we move forward, there's a little bit of a shortcut instead of solving a system of equations when you have linear terms. Now, just to throw this out there. So using our last example, when we had our numerators equal to one another, we were looking at this. Now, what x value would make this term go away? We would need this to equal 0, right? What makes that equal 0? Because then 0 times a is 0, and that term would go away. Good, -1. So I'll keep that in mind. So when x is equal to -1, that term will go away. Okay, so if I figured out what would make that go away, and then I plug that value in everywhere that there is an x in that original one, then I'm just going to simplify there, and this would be -3 minus 8 is equal to, this is the 0 we were looking for. 0 times a is just 0, so I'll put that as a placeholder. Now over here, what do we have? That'll be -6b. So we'll have -11 over 6. Oh, -11, excuse me. Getting ahead of myself. That is equal to -6b. And then if we solve for b, divide both sides by -6, and 11/6 is equal to b. Okay. Right, that's the same thing we got. And then from there, we could always plug it back in, and also we can either do that, or we can now turn around and ask the question, what will make this term go away? Okay, so we jump down here and we take the original that we had at first, and this time I'll say, well, what makes this term go away? What x value? So I'll do this one in red. When x is equal to 5, right? So then let's do the same thing. Everywhere there's an x, plug in a 5 and do that. Okay, so when we determine that, we plug 5 in. 15 minus 8, 7. Over here it simplifies to 6a. We get a 0 over there. Divide both sides by 6, and you can see that we got the exact same a and b values as we did using systems of equations, solving systems of equations. Okay, our next example, we can clearly see that we have 3 linear factors in the bottom right there. So when we break this apart, I want you to be able to determine our, let me do it in a different color. So we'll have a over the first factor, x minus 1, plus we'll have b over x plus 1. And since we have a third one, we'll have a c value as well. What I want you to notice is that none of these are repeating. There are not any repeating values, so that we'll have capital A, plus capital B over the next one, plus capital C over the next one. Of course, if they had a fourth one that was different, we would have capital D, so on and so forth. Okay, now pulling them all back together, let's take a common denominator, and I want you to work on your numerator. Okay, go ahead and check your work there. We'll need x plus 1, we'll need these two terms. For the b, you will need x minus 1 and x plus 4. And for the c term, you will need x minus 1 and x plus 1. So you should have that as your numerator. Okay, so let's bring our numerator down. So we'll have 4x plus 9 on the left. And just go ahead and carry that down. Okay, to solve this thing out, first of all, we'd have to FOIL that, then FOIL it out times a, and you could see algebraically how that could just be an extensive, not hard, but just tedious and time consuming. So using the method, the shortcut kind of method idea, why do you think I chose -1, -4, and 1? Well, if I wanted, just for example, let's say I wanted this term to cancel, I would use a -1. -1 plus 1 would give me a 0. 0 times anything is 0. Okay, same idea there. A -4 would get me a 0 in this term, and a +1 would get me a 0. So you could see why we are being purposeful in selecting that. So basically, we're going to have 3 cases. I'm going to do it one time when x equals -1, like we did. I want you to do a second time when x equals -4. And I want you to do it a third time when x equals 1. And then let's check our results. Okay. So plugging in a -1 into that entire equation, we can see some things are going to cancel. First of all, we'll get -4 plus 9 will just simplify to a 5 over here. What about a? When you get 0 right here, this whole term's going to cancel. So we can draw through that. All right, our b term will remain. So we'll have b, what's -1, -1? -2, good. And what is -1 plus 4? 3. All right, and we over here on the c term, this right here gets us a 0, so the c term zeroes out, and we find out that 5 is equal to -6b. Solve for b. So b equals -5/6. Okay, do the same thing when x equals -4, and also one more time when x equals 1. Okay, just to check your work, C will get -7/15, and when x is equal to 1, A is equal to 13/10. And to rewrite this left-hand side, using partial fraction decomposition, we have this as our A, B, and C are in place.